Hey, it's me, Owen. I'm recording another video as part of my Radical Software class about browser extensions. I'm going to cover basic introduction to browser extensions, how to install an in-development extension, and I'm going to go through 3 different sample browser extensions that are all fairly simple and do specific things. So first of all, what are browser extensions? So most people already understand an extension is basically a set of files, software that you install in your browser, and then it adds additional functionality. So most people know about ad block or ad blockers. There are a few different ones, and they have a set of scripts, and they add functionality. They look for advertisements and trackers and block them. I'm looking now at the Learn JavaScript page for browser extensions, where I talk about what they are and how to get started. Some of these details come from a chapter that I wrote with Joel Dietrich and Greta Lau in the Signal Culture Cookbook, Volume 2, called Browser Blowup, where we talk about browser extensions and web tracking, both as an artistic and creative and activist project or practice. And then we walk through how to build a browser extension. This tutorial, this whole chapter is linked from this document. So let's talk a little bit about the structure of a browser extension. The browser extension is divided up into specific sections that are considered different contexts, and this is so that the browser can still provide security for the user. So when you install a browser extension, typically you have a background script, and that runs. There's just one copy of that background script. While that extension is enabled and installed in your browser, it's always running. It might not be doing anything, but it's always available to run. It could perform some kind of timed action, but usually it's a kind of go-between for the content scripts. Every time you load a new web page that a content script has been given permission to access, a new set of scripts and extension assets are loaded into that browser page. So I'm in Google Docs right now. This is a Google presentation. So this is a good example. The Tally project, this is Tally. Tally is a person, a thing that hangs out in the bottom left of your screen and looks for product monsters and trackers on the web. And if she sees one, she will tell you that it's hiding on the page and encourage you to go and battle it Pokemon style. If you beat the monster, you actually block a tracker from that website on your in your browser. So it's a progressive tracker blocker / internet RPG because it works across the whole internet. Tally has a number of Easter eggs. For example, if you triple click Tally, she'll ask if you want to hear a joke. So we will. What do you get when you cross a cow with a trampoline? I don't know. A milkshake, of course. Yeah. Tally's into dad humor. So anyway, Tally has access to the entire internet. And so she's working on every page, but she does not have permission to run on Google Docs. And you can click the button up here at the top right, and where you can set the options, and you can tell Tally, or you can set where you want Tally to run or not. So Tally saves at internet.com. So Tally is a browser extension, and the content script is what loads Tally, the character. It loads the SVG files that make up her body and all the data that make up what she can say or do, and the scripts that perform the logic of the game. So the extension assets in the content script are loaded into the web page content every time it loads. The browser action, or pop-up, is what's accessible here. When you click this, this is a browser action. And really, they should have called them pop-ups because that's what they do. But so that's what we're seeing here is a custom page called popup.html with its own CSS, its own JavaScript. And this page cannot interact, this little page in this window cannot interact with this page. The pop-up cannot interact directly with the content, but they can both access the background. So they can send data. So it's getting data, etc. And I can change data. I turn this off. I turn that on. And so these are running. So when it does that, it's connecting to the background script, and the background script, because this game is saves itself on the internet, and also it's multiplayer, so it's comparing your score with other people on the internet. Then it connects to a web server and a database. So because of course you can only connect to an external resource like a web server or database from the background script. You cannot do it from a content script. So all this provides security for a user. So all of these files, the extension files, are described inside of the manifest. So we're looking now at, let's see, let's go. I have 3 extensions up. I have 3 extensions that they're all sample extensions. They're all linked from this page down here. So this is an example of a manifest file. Every browser extension has to have a manifest. It describes its name, the version, and what manifest version, the schema that you're using. And then you install it by going to Chrome extensions if you're installing it for Chrome, or this URL if you're installing for Firefox. And then you load unpacked extension and select the directory that contains your unpacked extension. Unpacked just means it's not zipped up. Here's the link for the browser blowup tutorial and another tutorial provided by the Mozilla Developer Network. And here are the links for the sample extensions. So we're going to first look at Github Tools and then the Observer and the Messages extensions. So this is where you install the extension. And when you do, you click Load Unpacked, and then you navigate to the file that has it, and then you select it. And I've already got this one installed, so it just refreshed it. And if you're doing development, you're working the code, and then you come back here and you hit refresh, and it refreshes the page, refreshes the extension files, and then you go back to the web page where you're testing, and you refresh that page so it can get the new extension files and inject the new content scripts. So the manifest file is what not only provides the metadata for the extension, but it also describes the icon and the scripts and the files for the browser action, the scripts for the background, and the content scripts. And they have it's a JSON file, but it has a very specific schema or set of key value relationships that you have to describe. For example, content scripts has to be an array with an object in it. So there are all these rules. So check the documentation. I have links in this page down at the bottom to documentation for developing Chrome, Firefox extensions, and developing cross-browser extensions. Typically, if you make an extension that works on Chromium browsers like Chrome, Brave, Opera, Chromium. It'll also work very easily on Firefox. And I think it might, because the Microsoft Edge is also Chromium based, it may work there, though I have not tested it. Soon I will. So, okay, so once you load this manifest file and you describe where all your files are, then it'll load all the files in your project. So I'm going to collapse these. So I've got, this is kind of my standard project architecture here. I have a GitHub repo project folder that has the settings and the README, and then I have an actual folder called extension that is where the manifest resides. So when you load this folder, it picks up this manifest and then loads all the content here. So let's look at GitHub Tools first. So these are the 3 extensions I have loaded right now, and GitHub Tools is an extension I made, and it really just does one thing. If you are on a github.com page, it will try to load the github.io page or the GitHub Pages page. And if you're on the GitHub Pages page, it'll try to take you back to the repo. And you get all this through a keystroke, command, or Control G. So I'll run that. There's no index file in here. This page doesn't have a GitHub Pages page, but I will go to a page that does to demonstrate. And go to my repositories and look at all the sample projects. I think this one does, or the milestones do. So let me try. So Control G. No, there's no GitHub Pages there. I should have prepared this before I started the tutorial, but all right. Let's keep. Oh wait, there we go. So my Dig245 project, all I have at GitHub Pages. Oh, and I can see them right here, GitHub Pages. So I could, if I'm on the .com, I could click GitHub Pages, and then I could view deployment, and then I can see the published HTML file. There's nothing special there, but but there's no way to get back. And so when I have students turn in these projects, I don't have an easy way to get back to the repo. So I'll be on the GitHub Pages. I just did this with the control. This is the single feature that extension provides. If I'm on the github.io page, I can come over here, cut the username, change this to .com, add the username here, delete index.html, and that's the URL for the repo. However, that's a pain in the butt. So what I did was I made this extension. If I press Control G while I'm on a GitHub Pages URL, it'll basically do that work automatically with JavaScript. And when you're grading, it's really helpful. But so anyway, it's a super simple extension. Like I said, it only has this single function. And so let's go look at the code now. So so I have 2 folders, assets and pages, and inside of assets we have the CSS that provides, there's a little bit of, let's see, so I click on the puzzle icon and there's the sample extension GitHub. I'll pin both of these up here. So it has a little bit of CSS to style this, and here are the icons that are required in the manifest file. There's the CSS, and the background doesn't have anything in it, so I just have this console log. And to get to the background, the developer console for the background page, you can go into Chrome extensions and click background page. And so we can see this is what it looks like. And so there are, it loads an HTML file, it loads a DOM just so it can run your background script, but it doesn't really do anything else. And if it used local storage, then you would see data here. It does not, but the messages sample does, and we'll look at that in a second. So that's the background script, and then the content script is a single JavaScript file, and it's loaded into, as you can see in the manifest, it's loaded into every single web page that either starts with GitHub or includes github.com or github.io. So it only runs on those. It only has permissions to run on those. When it does, where's the content script? So it uses Mousetrap, which is a super JavaScript keystroke binder, and so whenever you press Control G, it launches. It runs this launch GitHub function, and does a quick logic to determine whether we're on github.com or github.io, and then it gets a clean URL pointing at github.io if you're on com, and vice versa, and then opens a new window with the new URL. So the return clean GitHub.io and the return clean GitHub.com functions basically do the same thing. They get the URL and they split on the slashes, and then slowly pull apart the username, the repo, reposition them, and return a URL. So most of what this is doing is just doing the work that I just showed of moving all the strings around in the URL and then opening a new page with that URL. So very simple, and that's really all it does. And here's the popup.html that we saw earlier. So that's the GitHub Tools, and so it's pretty simple. It's basically just provides it's the simplest of the three samples. It just provides it just shows an architecture. The next one is a little more complicated. It's called Sample Extension Observer, and it also has nothing in the background, just a console log. And in the content script, its job. We'll look at what it does here. So again, the background page, if we look in the console, hello, doesn't really do anything. But if we go and look at what it does, is that it provides, I'm going to refresh the page and open the Dev Tools. And so it is I call it observer because it has a mutation observer in its code, and it looks to see if the page has been, if the DOM, the document object model, has been manipulated, updated, changed in some way. So when you go to Facebook or YouTube or Tumblr or whatever, and you scroll down and the web page adds content below and adds new elements to the DOM with new content, that's considered a mutation, and you can tap into that with a mutation observer. And so I have a single mutation observer with this configuration. It's looking inside the body, and I pass the target node in the configuration here. And so basically the observer looks like this. It gets the current date, it logs the number of mutations that it found, and then it loops through them, and it looks for a specific class called the class you are looking for, and if it finds it, it runs a little growl notification at the top. That class is added dynamically down here at the bottom, where I create a button and add it to the page. So this right here is the mutation observer button that is added, and if I click it, then it's going to actually add. Oops, sorry. This is the observer actually, because it's got the eyes right. And so if I click it, it's adding, if we're going to look down here at the bottom, check this out right here. So if I click this, it's adding a new paragraph called the class you are looking for. And the Mutation Observer is looping through, and if it finds that class, you could search for any pattern really, but we're searching for, see, we add this new paragraph right here, and then up here is where it loops through all the mutations. So basically every single thing that's added to the DOM, it loops through, and then it looks through the class list of the node that was added, the HTML element, and then it does a growl, which is that thing at the top. So every time I click this button, it's adding a new class here at the bottom, and then it's also detecting. It's basically detecting itself, which is odd, but it's a demonstration of what it's doing. So you would use this for if you make an extension that is somehow needs to do something in case the web page was updated. This happens a lot on Facebook, for example. They use React, the JavaScript library that allows them to refresh all the pieces of the website or the web page dynamically, including doing any kind of tricks to keep you from blocking ads. So you might use a Mutation Observer if you're building an ad blocker, for example. So that's a Mutation Observer. That's the Observer library, or not, it's the Observer sample extension. And there's the manifest. It's pretty much like the other one, and it does not. Here's the if you click on the pop-up, it actually does not have a pop-up. It just shows you the default browser options. So you can really see it in action here. If I refresh the page, refresh YouTube, and then scroll, then we can see just how much a web page is being updated all the time. So as I scroll, then the new mutations observed is that's what, and you can see like at one point it added 700. And so this is all YouTube, manipulating the content underneath. And so that's what the Mutation Observer provides. Okay, so the third extension, and the last one I'm going to talk about, is this messages. And it shows how the message passing works between pop-up and background, and content and background, and how data gets sent back to the content and back to the background. So I'm not using external resources, but that could be easily configured with fetch and a database or remote API. So let's take a look at what it does now. So this bird here is the third extension, the Observer. And I'm just going to turn off the other ones to keep this clean. Just turn these off right here, and then come back to this page and refresh. And so we've just got the bird now. So the bird has, let's look at here it is. So the bird manifest, or the sample extension messages manifest, looks like this. We've got a background script, content script, and browser action. And so the browser action's right here, and you can see we've got some options there. The content script is right here, and the background has code in it too. So let's show what it does first, and then we'll come back and talk about the code. So I think it's important to be able to see the background, what's going on in the background here. So I'm going to drag, this is the Dev Tools for the background for the sample messages extension. And just going to position everything here so it's easy to see what's going on. So I'm inside the DevTools inside of the application tab, and then local storage, and then I clicked on the Chrome extension. And so we can see that the sample browser extension is using local storage. We've got a key called score, and inside of that is a JavaScript or JSON object. And it has 3 keys: content clicks, content scrolled, and pop-up clicks. And each of these have separate values. So essentially, we're using the background and local storage to store data that is coming from the content script or the pop-up. And then we get that data back and see what the values are. So let's run that and see what happens. So when I click on the bird, then that's considered a content click. So every time I click, a message is passed into the background. We can see the console on the background. So there's this is the console for the background. This is the there's only one of these. And this is the console in the DevTools for this particular tab that I'm on, this web page that has the content script loaded. And they're both 2 separate lines of code. And so when I click to the bird, it's contacting the background, saving that data in the local storage, logging the value of score, and then it's replying to the content script, which is then logging its value. So I click, you can see that they both happen. So as I click, so in addition to the click action on the click recording on the content, I've also got a scroll. So every time if I scroll a whole bunch and then it doesn't work until I let go, and then once I let go, then that value is saved into the background. So every time I scroll, it goes to the background. And we can confirm that this is working. We can see the score object is being logged right here. We can see the application data is changing inside of local storage. And we can also see it's being logged right here, the data that's returned from the background. We can see that all 3 of these match. And this is using asynchronous communication. So I'm using callbacks and listeners to do this, which is what Chrome recommends. So this all this happening. Oh, and I should show the pop-up as well. So the pop-up, when you load the pop-up, it gets the latest data object. This is the score object that is coming from the background. So this right here is the same as the score object itself. And then this is some metadata that's coming that I've attached to all these messages. You can see them here. The action from the content script is increment. The message was success. And here, this just gets data. So when you click plus, it increments the pop-up clicks by the amount that I've determined. I've got a reset button that resets the entire score object, so everything just zeroed out. And then finally got a fail, which just shows what happens when you forget to attach all the details. It forgot to attach an action. And so that's what this looks like right here. So, okay, so now we see what it does. Let's look a little bit deeper at the code. And just to remind you this, so we've got all the browser extension files are right here. And the content is connecting to the background, and the pop-up is connecting to the background. So let's look at the content and the pop-up are kind of similar. Popup.js is being loaded inside of popup.html. So these are all the buttons, and then it's loading popup.js. So popup.js looks like this. Using jQuery, once the page has loaded, the DOM is built, we use a send message method on chrome.runtime, and we send an object. And that object has, and you can send any object. You could attach anything here. I've created a kind of schema here, so a sender and action, and so the action is get data, and so it sends, and then it waits, and it's got a callback function that will run once the response happens. So this happens, this is asynchronous communication. So if we go look in the background script, we can see that there's a on message listener, and when it gets a request, it logs the request, and then it gets the current value of the score out of the local storage using the local storage object. It says local storage get item, and then it looks for, you just pass the name of the key that it's stored under. In our case, it was score, as we recall, application score right there. And so, and then everything else is basically logic that I've defined, right? So request.action is a key or a property that I set on the request object. So this request object is whatever you want it to be. And so I did this in the tally game, and I think it's a good way, because you're sending a message and telling, you want it to do something. You're like, what's the action? And so if the action is to increment, then I know the background rather knows one of three things. It's a click from the content, or a click or a scroll data from the content, or a click from the pop-up. And so in each case, since I have the latest object out of the local storage, I can update whichever field is appropriate by looking at the field value, which again is set right here. So it's either a pop-up click, or if we look in the content script, we can see that it's a content click or a content scrolled. And so once the correct field has been incremented using the data in the request, again, so we got the sender, the action, and the field, and then finally the data where the value is. We set the item, so basically we just overwrite whatever the score value was with the new object. Note that we're using JSON parse up here. Once when we get it out of the, because it's stored as a giant string, and so even though it's a JavaScript object, it's still stored as a string. So you have to parse it to deserialize it and convert it to a real object that you can use. And then when you save it, you have to stringify it again. So it's this you have to convert it back to a string. So you can't use a JavaScript object when it's a string, because the keys aren't accessible in this method. So, and then we send a response using the built-in send response parameter or method that's a callback that's passed in the add listener. And then and again, these three keys are just custom based on, I want to tell the sender, which is either the pop-up or the content script, that the action was successful. I want to just kind of remind them what the action was, kind of thinking about it like it's an API, so I can keep track of what the action was that was successful, and then just share the data, the current version of the data, which is by going back to the local storage and getting the most recent one and parsing that so that it's a real object. And so we do that. If it's an increment, we increment the field and send the data back. If it's get data, then we just basically do this thing over again by just sending the data back. If it's reset, we call the reset function and send the data back. The reset function looks like you might expect. It's just a blank. It's an object with all the keys set to 0. it sets the item. And incidentally, we do this every time the on installed listener runs as well. So if you wanted your data to be permanent, you wouldn't do this, obviously. If you wanted to build up over time, I just did this so I can test. And then finally, if it fails. So we looked in the pop-up. So in the pop-up, this is the send message that gets the data, that sends the data, it's a request object. And then this is the function, the callback function that is called when it receives the response from the background after it does its work. And then it calls this display response function, which is down here. And all it does is just stick the data, the pop-up, it just sticks the data back in the field, stringifies the data. So that's how we get this. So it's basically just rewriting what's inside of this field right here. And I have 3 listeners with jQuery, the increment buttons. With each button, it's looking inside of the HTML to see what the value is, and each of the values matches the text that's in the button name. And then it sends the message. In this case, I have the whole object right here is the first parameter of send message. While in this one, I actually created a new variable called MSG to store the message, and then I pass it right there. Either way is acceptable. Sometimes I find it's cleaner to do it one way or the other, but I could just as easily had done this and put it right there. And then the reset button does the same thing with the action set to reset. This is the one with the action that didn't work. So that's the pop-up, and the content script is not that much different. It also has a display response function. It's a little bit different. It adds and removes a class called notify, which is just a little, maybe it's hard to see, but it's a little circle, a little border to the chicken. And so just like in the pop-up, we have to wait until the document is loaded. We inject the button in the page, in the content of the page itself. And then we add a query selector so that we can listen for clicks on the button. If there is a click, we add the notify class, which is, like I said, it just changes the border. It looks like this. It just changes the border from orange to light orange. And then we build a message object coming from the content, telling it to increment is the action, the field was content clicks, and just one. And then we display the response. And then the last bit is the code for the scroll, which is a little bit more complicated. I copied and pasted this from the Tally project, which also has a scroll function, and I'll show you what that badge looks like, because I'm pretty happy with it. I'll go over to the leaderboard, and we'll find maybe we'll look for my character, my player, because I know that I've got that badge. And it's called the long distance scroller, and so I'll just search for it on the page. So it's been keeping track for a few months now, and it's 37,000 meters have been scrolled. The long distance scroller badge is right there. So it's I'm a level 37. It's the number of kilometers that you have scrolled. And if you go back to the leaderboard page, you can see the total number of kilometers that players have scrolled, 401 kilometers, 401,000 meters. So basically every click of the mouse wheel is a millimeter, and then we keep track of that. So hope to add that into the timeline eventually. Okay, so anyway, I'll just kind of run through it. We're using jQuery to listen for the scroll, and because the scroll there's a kind of because this function is constantly listening. There's a little bit of a timeout to know when the player has or the user has done scrolling, and then we basically do the same thing here: send a message to the background, reset the current scroll distance in the content script because that data has already been updated in the background. Yeah. So let's see, any final thoughts on browser extensions? Oh, there's a product monster. I don't know if I have sound on right now, but I'm listening to a really like a chiptuned version of the battle music right now, and I can launch attacks, and when you see the game shake, it's because the browser extension is grabbing all the elements of the page and exploding the page. And that's a random attack. We never know what you're going to get. I'll keep playing. Maybe I can. Oh, that's a random defense now. I'll keep playing and let's see. I think that memory flare is a good one. Let's try that. Oh yeah. See, I'm a level 35, while the cycling monster is only a level 20. Let's try it again. Oh, one more hit, and this cycling product monster is done for. Uh-oh, a bug. It's constant. It's a constant problem. There's always a bug somewhere. So that's what the page looks like when it's exploded. It's quite fun. It's a really fun game to work on, and browser extensions are really fun. And I really can't say enough fun things about browser extensions. So when you click, the page will reset. It'll just refresh itself. So yeah, FAQ and tips, documentation. What else can we say? Just remember that whatever JavaScript or CSS that you're injecting into a content script, that it can be affected by whatever CSS is built into the page itself. And so you can do this by explicitly setting a default for every property in your extension in your display, which is kind of a pain, but that's just how it works. So take, for example, this button right here. This is my chicken button, and you can see that it inherits from my injected style sheet, which is this class. But then everything else is things that I did not set explicitly are inheriting from the content of github.com's page, this base, and their normalize file, and anything else that I didn't set. So that's just something to watch for. So anyway, I think I'll end it here. So I'll recap what I explained, and then we'll end the video. So we walked through what browser extensions are, how you create a development extension, what a manifest.json file is, basic architecture of of browser extensions, and I walked through the setup for 3 different sample browser extensions that are all on GitHub, all MIT licensed, and you can check them out. And of course I did some Tally saves the internet promotion, and so that website is right here. You can find it right there, and watch the game trailer and check out the game, and it's quite fun. Go play it.